Welcome back. We are on 8-4. We're still multiplying binomials, but these are called special cases. So for some reason, these are extra fancy smancy. And they are just as easy breezy. If you thought 8-3 was pretty okay, you're going to think 8-4 is pretty okay. But I noticed some kids get stumped on these. They're like, oh, this is easy. I already know the answer without any work. Yeah, please don't do that technique. I know that technique. Kids are trying to cheat the system, and they're thinking, oh, the answer is just 16p squared plus 4, because I'm going to square that, and I'm going to square that. That is not the answer. It is not the way we work with this. So on 8-4, this is the first question. Make sure you printed the notes. Make sure you copy down the notes, and here we go. This little 2, what is it saying? We got to read it like a sentence. What does that power of 2 mean? Anybody? Anybody? Kids in the back? Somebody? That's right. It means I have 2 of these. And if you're a visual learner like me, let's show it. So the first thing I'm going to do is I'm going to write it out twice. So I have 2 of these binomials. Well, instead of just thinking about it, well, let's write it out so we can visually see it. And then we can use one of the techniques that we used previously. We can use the Punnett square if that was your jam. We could use happy face guy or the wave method or FOIL. Whatever worked for you, I would say use it. So here we go. That's 16p squared plus 4 at the end. Let's do the middles. That's weird. The middle doubled. Huh. And if you notice, these are the exact same binomials twice. And the middle doubles. Huh, I wonder if that happens all the time. I don't know. We have 16p squared plus 16p plus 4. Notice I showed work. Notice my answer is in proper order. 16p squared plus 16p plus 4. And notice that that middle doubled. 4 times 2 is 8p. Double that, 16p. That's weird. Yeah, it is. Let's go ahead and skip to question 3. Yes, I'm skipping to question 3. We'll go back to 2. 3 is just like number 1 on the note. So let's give this one a little rumble here. We have x plus 5. We have 2 of them. Remember, that power of 2 says, hey, person staring at this, there are 2 of these. Now use whatever technique you like, FOIL, Punnett square, happy face guy, distribution. You can call it churro for all I care. Just get it done. Here we go. X times x is x squared. 5 times 5 is 25 in the back. And the middle is right there. Looks like a little happy face guy if you stare at it long enough. Wow. It doubled again. When I have this squared binomial, the middle always just doubles. That's interesting. Cool. So there's our answer to question number 3. Let's go back to question number 2. First of all, we do not have the same binomial twice. They look similar, but they have different signs. When you have binomials that look like this, we call them conjugate binomials. Conjugate binomials. What does that mean, Mrs. Miller? That's a funky word. It is. Conjugate binomials just basically means, I'm going to give you the basic, same junk, different signs. I wonder if this time the middle's going to double like we saw in questions 1 and 3. I don't know. Let's check it out. If you want to use Punnett square, whatever technique, again, this is up to you. So here we go. We have 25v in the front, v squared. We have the back numbers, 9. We have the middle, cool beans, looking pretty promising. Whoa, what the heck just happened? Negative 15v, positive 15v. Wow, the middles canceled. We only have the first term and the last term. Huh. Our middle terms cancel when we have conjugate binomials. Same junk, different signs. Let's look at question number 4 and see how that's rocking and rolling. Question number 4. So here we go. Again, we're on 8-4 notes still. So question number 4 on the notes, we have 6n plus 4 and 6n minus 4. What do we have? Do we have the same binomial twice? Or do we have that thing called conjugate binomials? Same junk, different signs. Conjugate binomials, we know that the middle term cancels. Let's see. Ha! It worked again. Conjugate binomials, our middle term cancels. And now we are left with a beautiful binomial of 36n squared minus 16. Again, when we have the same junk, different signs, called conjugate binomials, we're going to have a middle term that always cancels. And what we're left with is the front term and the back term. So this is my final answer. This is with all work shown. Now I want you guys to try questions 5, 6, 7, 8, 9, and 10 on your own. So the next 6 you do. Take notice. Do I have conjugate binomials or do I have the same binomial twice, which tells me that my middle term will just double. So you go ahead, tackle the next 4. Happy learning. Bye.